This is ACT Math Manual Section 8. Section 8 deals with percents. Now, students generally, as is true with a lot of concepts, students run the gamut with percents. Some students are extremely confident with percents. Other students struggle a little bit with them. Obviously, percents is also one of those places where students have their own ways of doing things, and for a lot of students, those ways work perfectly well. I'm actually going to be teaching percents in possibly a slightly different way than what students are used to, and I'm teaching it this way because this way tends to be the safest and most effective way to handle percents on standardized tests like the ACT, because of the way percent questions tend to be posed on a test like the ACT. I'm going to teach this in a very specific way. Some students might find this way a little bit difficult at first, but I promise that with practice, this will become very robotic and second nature. It does for the vast majority of students. So before we get into that specific technique, I need to point out that the word percent has a very specific meaning, which most students are aware of. But if you notice, the word percent is made up of two parts, the word per and the word cent. Per plus cent. The word per means out of or divided by. That is what per means. For instance, when we say miles per hour, we are saying miles divided by or over hours. So again, the word per translates to division, and cent is the Latin root for 100. So the word percent really does translate to divided by 100. Now, why is that important? It's important because every now and then on the ACT, when students see a strange percent, for instance, if ACT were to throw a student something like this, 0.2%. Now, they don't do this often, but they could. A lot of students are hesitant. A lot of students will make careless mistakes when it comes to translating this to a decimal. In fact, right now, if you want to do a little exercise, pause this video and tell me what 0.2% equals as a decimal. Obviously, you can't tell me it, but you could write it down right here. A lot of students will say one of a couple of things. They might say 0.02, they might say 20, and they do this for various reasons, but probably the most common reason is that in school, you were used to moving between two forms that tended to look like this, where you had a decimal and then two digits, or just two digits as a whole number before a decimal. And again, generally you moved between two forms that look like this. So when students see 0.2, they a lot of times will just think 20. They'll think 20%, but this is obviously not 20%, it's 0.2%. If you are always thinking of the word percent as meaning divided by 100, then you can just translate. There's three things here. There's a 0.2, there's a per, and there's a cent. So what this translates to is 0.2 divided by, which again is the per, 100. And then from that point, you can use your calculator to just do 0.2 divided by 100, 0.2, let me clear that out of there, 0.2 divided by 100, and then you can let the calculator do the work for you. So this equals 0.002. Now, of course, if you didn't have any problem with that whatsoever, if as soon as I said, what is 0.2%, you thought 0.002, then great, good for you. You're solid. That's awesome. But for those of you who are a little shaky on percents or might tend to get fooled by something like 0.2%, I would make sure that I am always thinking of the word percent as a translatable word into divided by 100. So whatever comes before the word percent, you just put it over 100. Now, in terms of percent translation, what we just went through gives a nice little segue into percent translation, because indeed in this percent translation chart, which I would sincerely suggest that you simply memorize if you are by any chance shaky on percents, or you tend to make careless mistakes on percent questions. As I said, I would memorize this chart, but you can see the first word in our percent translation chart is the word percent, or the percent symbol. And whenever you see that word percent or the percent symbol, again, I want my students writing over 100. So if you see, as we did up here, 0.2%, you do 0.2 over 100. If you see 10%, you do 10 over 100. If you see n%, you do n over 100. So anytime you see that word percent or the percent symbol, that translates as over 100. So before we move on, just so you know what we're doing here, again, on the left we have some visual tip-off clues, some words, some phrases that tell us what we are going to write. And what we are going to write in terms of symbols or algebra will be over here on the right-hand column. So we are taking words and phrases and we are translating them into an expression or equation. What number, a value, these are all unknowns. So these translate to x's or n's or y's, whatever you want. What percent is just a combination of these first two items. What, we said, was a variable, and percent was divided by 100. So when we see the phrase what percent, we are going to translate that as x over 100. What percent? Is, are, was, were, those are all words that indicate an equal sign. So if we see an is, we are going to translate that by writing an equal sign. Now of, some students do think of is division, but it is not. Of is multiplication, and then these two are the really simple ones, plus and minus, increase by and decrease by, respectively. Now what do we do with this chart? Well, we do what I just said. Whenever we see one of these items in the left-hand column, we're going to translate into an algebraic expression or equation based on what's in the right-hand column. So in example 1, we'll do this one together. If you want to try it on your own, you can always press pause, but this is how the translation would work. We would have 54 is, remember we said that the is translates to, I'm going to zoom in on this a little bit, the is translates to an equals sign. 75%, remember percent is divided by 100, so this is 75 divided by 100 of what number? We said what number was an unknown, an x. So now what we have is this basic algebraic equation that we can go ahead and solve. Now listen, if you are used to doing a percent question like this in a different way, for instance, if you're used to setting up a proportion like 54 out of something is 75 out of 100, that's perfectly fine. Again, if you are really solid with percents and you are really sure of yourself on percent questions, I don't really have a problem with you doing percent questions in this way or whatever way you're comfortable with. However, as I've said before, there are going to be some questions on the ACT that are more amenable to this pure and simple left to right translation technique. So my suggestion to you would be to learn it and learn it well. Now, in terms of how to solve this, there are a couple of hints over here to the right. One hint tells you to take any integers or variables and put them over 1 so that you basically make fractions out of everything. And then another hint is that fractions can just be multiplied straight across numerators. So if you had an x in your equation or you had a 3 in your equation, generally it's a good idea to just put those over 1. And if by some chance you were multiplying them, well, that's where this second note comes into play. Remember, you just multiply straight across numerators, straight across denominators. So this was a silly example. Let's do 3 over 2. So x times 3 is 3x and 1 times 2 is 2. So you can just multiply straight across numerators and denominators. So how would that apply to this equation that we've derived? Well, I'm going to put this 54 over 1 and I'm going to put this x over 1, and now I'm sort of going to collapse everything down. So this is going to be 54 over 1 equals 75x over 100. Again, I'm just multiplying straight across numerator, straight across denominator. And now I have what looks like a very simple proportion. I'm just going to cross multiply. 100 times 54 is 5400. And the 75x times 1 is obviously just 75x. Let me bring this over so I don't run out of room. And then to finally solve for x, to isolate x, I divide both sides by 75 and I get x equals, and obviously I'm going to do this in the calculator, 5400 divided by 75, 5400 divided by 75, and I get 72. So that number 72 is this right here. 54 is 75% of 72. We just solved for the what number, for the x. So that's the first one. Now that you've seen an example, if you want to go ahead and do examples 2 and 3 on your own, great. I'm going to go ahead and work through them right now. So example 2, 15% of what number, that's what we're looking for. 15% of what number is equal to 35% of 120. So again, here comes the translation. So we have 15% of what number is equal to 35% of 120. There's our equation. Now we go about solving. Remember what I said? Put all your variables, all your whole numbers over 1, multiply straight across numerator, straight across denominator, straight across numerator, straight across denominator. So on the left, we would have 15x over 100. On the right, we would have 35 times 120. Again, that is a calculator calculation. 35 times 120. We hit enter, so that's 4,200 also over 100. Now listen, I need to say one more time, just in case anybody's sitting out there going, why the hell is he doing it like this? There are other ways to solve this equation. There's other ways to simplify and ways to cancel. I generally don't recommend doing things in those ways because students tend to make careless mistakes when they cancel and try to get fancy schmancy. So as of right now, what can we do? We can cross multiply. Yes, you could cancel these hundreds or you could reduce these zeros. Again, a lot of different things you can do. I'm just going to cross multiply. I think that's the most straightforward way to go. So this is 1500x, those two equals 42. And then the 2 zeros here and the 2 zeros here. Of course, I could use my calculator for that as well. I'm going to divide by 1500, divide by 1500, and I'm going to go in the calculator and do 4, 2. I'm going to make sure I have the right number of zeros. There's 4 zeros there. So 1, 2, 3, 4 divided by 1500, and I get 280. So my final answer is x equals 280. And again, that answers this question. 15% of 280 is equal to 35% of 120. And I could check that in the calculator by doing 15% of 280, and I get 42. And then 35% of 120, and I don't get 42 because I didn't enter 120 there. Come on, Mike, watch what you're doing. Let's do 120 and I'm gonna get 42. There you go. Got to be careful with the calculator. So anyway, I do see that I have a match. I have that the two sides of the equation are equal to each other. Now, this last one is definitely the trickiest one, but again, if you are translating, you should not have a problem. We have this, 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 and this. So 0.25 is what percent of 0.2? Of 0.2. You got to be careful with that multiplication sign and that decimal. Maybe putting this in parentheses might be better here. But I'm going to go ahead and put the 0.2 over 1 and the 0.25 over 1. Again, straight across, straight across. So I end up with 0.25 over 1 equals 0.2x over 100. I cross multiply. These two are going to be 25. could do that in the calculator if I needed to, equals these two, 0.2x. I divide by 0.2, I divide by 0.2, and I get that x equals 125. And again, that should be done in the calculator. Now, when I get out this 125, again, that is what is going in for this what. So I have just answered the question and found out that 0.25 is 125% of 0.2. Now, some students look at 125 and get a little bit confused because they say, well, wait, how the hell can you have 125% of another number? Well, if one number is bigger than the other number, then indeed it's going to be over 100% of that other number. So it's perfectly legal and acceptable to have a percent that is over 100, depending upon the question. So the answer here again is 125. So that is percent translation, and again, I'm telling you, if you memorize that percent translation chart and you use it like a freaking robot, and take any thought or emotion or hunches or anything else out of the equation, no pun intended, you're going to be fine on most percent questions, especially those that pure and simple test translation, and there are a lot that show up on the test. Now, percent increase, decrease, things get a little bit more complicated here, possibly for some students. Percent increase terminology. So anytime you see a question that says percent more, percent added, or even a question that involves sales tax, percent decrease, percent less, reduced by a certain percent, discounted by a certain percent, all of these words over here indicate that you're dealing with a percent increase. All of these guys indicate that you're dealing with a percent decrease. Now, how do you do these questions? Well, again, some students have their own methods, and if you have a method that works for you, that's perfectly fine. I'm going to take you through the method that I have found to be most effective for the majority of students, also the methods that tend to reduce the risk of a careless mistake. Now, with examples 1, 2, and 3, if you want to go ahead and try them on your own to see how you are with these, by all means, go ahead and do so. However, I would still pay attention to the way that this is being done so that you have a concrete and reliable way of attacking these questions. So I'm going to do example 1 and possibly another 1 or 2 of these examples in multiple ways. I'm going to do example 1 with a 2-step method first, and then I'm going to show you the 1-step method. And if you are fairly confident with percents, then you either already know the 1-step method or may want to use the 1-step method. The 2-step method, even though it is more steps, can be a little bit more intuitive to certain students. So the 2-step method here would be to first calculate 30%. So we need this whole thing is the question. So we need to calculate 600 decreased by 30%. I need to say one important thing before we start this. A source of careless mistakes on a question like this. So 600 decreased by 30%. Some students, if you are not one of them, then that's great, good for you. But some students do think that they can simply do 600 decreased by 30%. So they'll get something like 599.7 or something like that. That's what this would be. You have to understand that you can never put a percent alone into a percent increase decrease question. There always needs to be a number after the percentage that you are taking that percentage of. In other words, when a question says 600 decreased by 30%, there is an unwritten 600 here, an unwritten of itself. Okay, either one of those. So 600 decreased by 30% does not literally mean 600 decreased by 30 over 100. It means 600 decreased by 30% of itself, or of 600. So you have to understand that, or else, again, you're going to make a careless mistake on a question like this. So the first way we're going to do this is as follows. We're going to find out what 30% of 600 is. 30% of 600 is, and when we do this in the calculator, we're going to get 180. So 30% of this number, 30% of itself, is 180. So what we are doing is we are decreasing 600 by 180, and that just involves doing 600 minus 180, and we get 420. So that's the sort of two-step method. Now, if you wanted to do this in one step, here's what you need to think about. If you were to walk into a store and you saw something for $600, but the sign next to that thing for $600 said 30% off, what I would ask is 30% off is the same as what percent of? In other words, if you saw a 30% off sale, that would be the same as a what percent of sale? And the answer is 70%. If you take 30% off of something, you are going to pay 70% of that thing. So the one-step solution here is simply to take 70% of 600, and then you get 420. So again, either of those methods would be perfectly fine. Notice they both involve some kind of translation. They both involve what we did on the previous page. Now, example 2, I'm gonna actually do this with the one-step method. If you want to do it with this two-step method, that's perfectly fine. But 10 increased by 35%. Well, remember, a number increased by 35% of itself is going to be 135% of that number. If you pay for a certain item, but you pay a tariff or a tax of 35%, you're going to pay 100% of the number, and then you're going to pay an additional 35% of the number, meaning you're going to pay 135% of the number. So I am simply going to do 135% of 10, and that is going to equal 13.5. Again, I could calculate 35% of 10 and then add that to the 10. That would be perfectly fine. That would be more like this method over here, but this is the one-step solution. Example 3, I'll do this with the two-step solution. So 15% less than 75 is equal to what number? So 15% less than 75 means 75 decreased by 15% of itself, or of 75. So this one I'm going to do in the calculator. 75 minus 15% of 75. Now, to be safe, I probably should have used some parentheses in there, but I am telling the calculator the correct order of operations, and indeed 63.75 is the correct answer. 63.75 is what I get when I reduce 75 by 15%. So this is 63.75, and again, this one was 13.5. So that's a little bit of background on percent increase, decrease. Now, number 48 involves multiple percent increase and decrease changes. The 2 or 3 things you need to keep in mind on a question like this, and these are fairly common. First is that there is almost always a fool's gold answer or a bait answer on these questions, and it involves this little tricky thing here, and that is that if you go up 50% and down 30%, a lot of students are simply going to combine these into 1% change, and they're going to say that you are going up a net total of 20%. So instead of doing a question like this 1% at a time, they're just going to say, oh, well, I can get to the result in one step, and I know that I'm going to increase 20%, and they're going to pick answer choice J. Answer choice J is a big time bait answer, a big time trick answer on a question like this. It's possible even answer choice G, which is just a decrease of 20%, is also a bait answer. The way that you don't make that careless mistake is you make sure that you treat the two percent changes separately. In other words, you do the first one and then you apply the 30% decrease to the result of this first change. So that's the first note. You have to do these one step at a time. The second note, so this is all number one. The second note is you can very, very frequently tin on these questions. Notice that in number 48, they just say a number. Well, that leaves us open to throwing in whatever the hell we want for that number. And I will tell you that you almost always, on a percent increase decrease question, you almost always want to throw in the number 100. Why is that? Well, the number 100 tends to be very easy to work with in percent questions. For instance, if I say that I'm increasing 100 by 10%, most students know right away that that would give us the number 110. If I am decreasing 100, so increasing 100, decreasing 100 by, let's say, 5%, most students would be able to tell you that gives you the number 95. So using 100 on a question like this will make your life quite simple. You might not even have to use the calculator, at least for the first percent change. So let's see how this works. They say a number is increased by 50% and the resulting value is then decreased by 30%, and then they want to know final number is what percent of the original. Notice that's a translatable statement. Final is what percent of original. So at the end of the question here, we might do a little bit of translation. So remember what we said. We said we're going to make the number 100. The first phrase says that that number is increased by 50%. Well, 100 increased by 50% of itself is going to give us 150. 100 increased by 50% of itself is going to give us 150. So after this first phrase, we're dealing with 150. Now they very clearly say the resulting value is decreased by 30%. So this number, 150, we have to take away 30% of 150. So 150 minus 30% of itself is going to give us 105. So the final step here, and by the way, you can just use your calculator for that. Keep in mind you could have also taken 70% of 150 because we're decreasing 150 by 30%. That's the same as taking 70% of 150. So the final calculation here, this says the final number is what percent of the original. The final number is what percent of the original. Cancel, cancel. There's our answer. This is not only the final number, it is also the percent that we need. And that is yet another reason that starting with 100 makes our lives so simple, because the relationship between the starting number and the final number will be very clear. Just to give you a couple of other examples on that, if you start with 100 and you end with, let's say, 98, well, if ACT asks you by what percent did this decrease, the answer would be 2%. And if they ask you this number, the final number is what percent of the initial, then the answer would be 98%. If you start with 100 and let's say your final number is 110, well, again, if they ask you what the percent change was, the percent change is 10%. And if they ask you this number is what percent of this number, then it's 110%. So finding the percent change or finding final numbers, what percent of the initial number, both of those tasks are very easy when you use 100 as your starting number. Now, I am actually sorry if you wrote this down, good for you, but I'm going to actually get rid of this because I need this room back here. So calculating a percent change. So on the previous questions, all the previous questions, we had this situation where we had a starting number, a percent change, and then a final. And in all of the previous questions, we were given this, and this was the unknown. This was what was left to be found. But if ACT gives you a start and a final, they may ask you what the percent change was. And in this scenario, there is a formula that you need to know and love and memorize. And that formula is this. It is the change in value, which I'm just going to write change in value. And I'm going to put that in absolute values. Keep in mind, change in value is also final minus start. It's another way of writing change in value. This symbol, this delta, means change, in case you didn't know. So the change in value over the starting value or the original value times 100. This formula will give us the percent change, the increase or the decrease. So as a really silly, easy example, let's say there was a pie for $12 that got marked down because it was a few days old, but it looks tasty and you want to buy it and you want to figure out what the percent decrease is. Well, again, we do final minus initial, that's the change in value, but we put that in absolute value, over the initial, and we multiply that by 100. So this is going to be 2 over 12 times 100. This is going to be 16.7%. So when we go from $12 to $10, we have experienced a 16.7% decrease. Not bad for a day-old pie. Now, example 5 is just sort of a plug and chug question. Now that you know the formula for percent decrease, percent increase, or percent change. A coat originally priced at $80 is discounted to $60. What is the percent of the discount? In other words, they're asking what is the percent decrease here. So again, remember what we do. We do the change in value, which is final minus the initial. Okay, final minus initial. And we do that over the initial, okay, the original. They tell us the original was 80 and we multiply by 100. So this is going to be 20 over 80 times 100. 20 over 80 times 100 is going to give us, and we could do that in the calculator if we were unsure, 25%. So again, they were asking percent of the discount. Indeed, that's what we just found. This thing was discounted by 25%. Now, you have to be slightly careful on these questions to make sure that the denominator is the original value and not the final value, because if the denominator is the final value, you are almost assured of getting one of the other answers. This question is no exception. So if we had done 60 minus 80 over 60, in other words, over the final value, we would have gotten answer choice E. We would have gotten 33 1/3%. So you do have to be slightly careful, not slightly careful, very careful about basically just memorizing this equation. I'm going to actually go ahead and highlight this equation. This is an important equation. It is not going to be given to you on the test, which means you should have it memorized. Anyway, that is it for percents. I understand that some of this stuff might not meld well with the way that you learned percents in school. I understand that this might seem like a brand new method of attacking percents, but I am telling you that for the purposes of this particular test, this percent translation method will likely help you / save you on certain questions. So make sure you memorize this chart, make sure you understand how to translate, and then obviously how to solve algebraically. That's, probably 70% of the battle. The translation is the easy part. Percent increase, decrease. Remember, there's a couple of different ways to do percent increase, decrease. You can do it with the 2-step method or the 1-step method. And then do make sure that you memorize the percent change formula. It does show up every now and then.